What is a p-value and how do you calculate it? That's what we will be discussing in this video. So the first thing we need to know is the official definition. So your p-value is a probability. So that means it has to be between 0 and 1 of getting your sample or a sample more extreme than yours, assuming going in believing that your null hypothesis is true. So the underlying functions that you need to know how to use here are the normal distribution and the student's t-distribution. So if you're a calculator person, the function that you're going to be using is normal CDF. And if you are a calculator person, then the function is tCDF. And if it's a student's t-distribution, tCDF. Both of these are located under second and vars button, which is your distributions button here. If you're a stat crunch person, then you're going under stat and calculators. Then you're finding normal or you're finding t. So let's look at this example, and we have to discuss the entire process of hypothesis testing to understand what this p-value gives us. So here we have a two sample mean problem. We're comparing school teachers, married school teachers with single school teachers. And we're looking at a proportion here. We're looking for the proportion of married school teachers who have a second job versus the proportion of single school teachers who have a second job. And what we want to know is, do married school teachers hold second jobs at a higher rate than single school teachers? So let's approach this from the p-value approach of hypothesis testing. So what we would do in our calculator, since this is a two sample proportion problem, we would go to stat, and then we would go over to tests, and then to prop z test, because we have two samples. Then your x here is the number of people that have a certain characteristic. So whatever is listed first in the problem, that represents your x sub 1. So you're looking at married school teacher who holds a second job and is 42% of the 500. So you can let the calculator multiply for you. Sample size of 500. The second sample represents your single school teachers. And once again, same thing. You can let your calculator perform 35% of 400. And our sample size is 400. Do married couples, married school teachers hold second jobs at a higher rate? That's why we have a right tail test here. And we're going to calculate this value. So from this screen, you get a lot of good information. So this line is your test statistic. This represents your sample. So your sample of these two groups. So that test statistic is generated from this beautiful formula. So you have your sample proportions and then you have your population proportions as well. So you have a simplified version down here when you have a pooled estimate. So that's what the calculator does for you when it gives you your test statistic here. So what your p-value is, the p-value is given to you right below, but how that number is generated is you're finding the probability of getting this test statistic or something more extreme than this. So if you look at our graph of our normal distribution, your test statistic is 2.1405. So what we're going to do is find the probability of getting this number or something more extreme. And since it's greater than, you're picking greater than sign here. So Z means we're working with the standard normal distribution. So we're going under distributions, normal CDF. You're finding the area to the right of that test statistic. So we enter your test statistic 2.140518. And you want the area to the right, a value more extreme than that. And once again, we're picking the right because this is a right tail test. Mean 0, standard deviation 1 from your standard normal distribution. and there is your p-value. So your p-value is the probability of getting your test statistic or something more extreme, and extreme depends upon the type tail test you have. So let's look at another example. Here, you're working with a mean problem instead. So when you're working with mean problems and you don't know the population standard deviation, we're working with the t distribution, specifically the student's t distribution. So our null hypothesis is that the mean miles per gallon is 27, and we're looking for, is there a significant difference between the two? So for my stat crunch people, then where you would go in order to do the complete hypothesis testing for this is you would go under stat, you would go under t-stats. We have one sample here with summary. So our sample mean is 28.6. Our sample standard deviation is 2.2. My sample size is 30, and we're doing the hypothesis test, so you can associate this with the p-value. So our null hypothesis is that the mean miles per gallon is 27, and we're looking to see, is there a significant difference? So two-tailed test not equal to. So here is your test statistic, the probability of getting our sample or a sample more extreme than this, and here's our p-value that's associated with it. So how that p-value is calculated, since you have a mean problem, you're working with the student's t distribution. So now you'll be using the stat calculator's t. Your d of f is your degrees of freedom, and your degrees of freedom is your sample size minus 1. So you had 30 randomly selected pizzazzes, minus 1 gives you 29 degrees of freedom. And this is a two-tailed test, which means you're going to have to find the probability of getting your test statistic and something more extreme, and then multiplying it by 2 because it's a two-tailed test. So let's change this to greater than or equal to, and our test statistic 3.9834368. So here is our probability, and we need to multiply it by 2 because that's just the value on the right, and this is a two-tailed test, so you also have to make sure to multiply it to put it on the other side as well, and that's where your 0.004 comes from. If you're a calculator person, then you're going under stat and then t-test. Your null hypothesis is that the mean was 27, your sample mean 28.6, your sample standard deviation was 2.2, our sample size was 30, we had a two-tailed test. Here is your p-value. You have to be careful with scientific notation, so you have to move that decimal 4 spaces to the left. That's why it's 0.0004. You have to change that into scientific notation. In order to calculate this, you take your test statistic, which represents your sample. We're going under distributions, and then you're going to t-CDF. So go to the right because your test statistic is positive, so 3.9834368. Upper bound is positive infinity, double E99, degrees of freedom, sample size minus 1. You have to take that value and multiply it by 2. There's your scientific notation format. You have to change it back to a decimal. So one more example. For a test of H sub 0 where your population proportion is 0.5 and they give you the Z test statistic. Automatically, since this is a Z test statistic, you know it's a proportion problem and you're working with the standard normal calculator. So find the probability that the alternative hypothesis P is greater than 0.5. So since it's Z and it's a proportion, that means you need to go under normal CDF. Here, P is greater than 0.5, so you have a right tail test. So you're looking to the right of this test statistic. So your lower bound is 0.75, your upper bound is positive infinity, your mean is 0, your standard deviation is 1. So your probability is 0.227. If you're a stat crunch person, you're under the stat calculators normal because this is a proportion problem, because it has Z, and you're changing your inequality sign to greater than or equal to. Your test statistic is 0.75. So the probability of that happening, your p-value is 0.227. Second example, find the probability of p not being equal to 0.5. So here you have a two-tailed test. So you find the probability of getting your number or a number above it. We're using above because your test statistic is positive, and you're multiplying it by 2 because you have to duplicate it, one on both sides. So we're taking that 0.227 and multiplying it by 2. So 0.453. Now you want to find the probability of p being less than 0.5. So there are two different ways that you can generate this answer. One way is you can do normal CDF all over again, left-tailed test. So now your lower bound is negative E99. Your upper bound is your test statistic, 0.75. Your mean is 0. Your standard deviation is 1. So you have that as a probability, or you know that it's the complement of the first part. So you could have done 1 minus 0.227 as well. Hope that helps. Have a great day.